presentation. How about in Korea now? Are you in Korea?
Yeah, I'm in Korea, and now hot and humid. It's
Okay.
whether it looks like Indonesia.
Oh yes, yes, yes. You have been in Indonesia how many times?
Yeah, 3 times, 2 times in Bandung, 1 time in Kalimantan.
Oh, in Kalimantan.
Yeah.
Oh, where the place in Kalimantan?
In Korean company plywood mills and on their acacia wood land and what palm oil and
okay.
acacia wood.
Okay.
Yeah.
Okay, acacia. So yeah, how about the other island? Not yet.
Bandung.
Sulawesi.
Yeah.
Yeah. Only Java and Kalimantan.
Yes.
So you have a student from Kalimantan, right? Rahmini.
Oh yeah, once she graduated about 1.5 years ago. Yeah.
Yeah.
Yeah, she was my former graduate student. Yeah.
Yeah. Now she is in Jakarta or Bandung, I think. Yeah.
Oh, okay.
We just wait a few minutes before start.
Right now, I have 2 graduate students from the Indonesia.
Oh, really?
Yeah, they come from the different island.
Okay, where is it?
I don't know, but east of the Kalimantan, not the different island, but east side of the Kalimantan.
Oh,
yeah.
Oh, east side the Kalimantan.
Yeah.
Okay. So they are master or doctor student?
Yeah, one from the master. No, one from master and one from the master and PhD together. Yeah.
Miss Putri. Miss Putri.
Yes, sir.
Before we start, is there any master ceremony? We will talk first, and before I will proceed this summer course. Is there any MC or master ceremony?
No, sir.
Oh, just directly. I got this today's summer course. Putri. So
yes, the moderator will guide the session.
Okay, the session. Okay. How many degrees now in Korea, Prof? Prof. Shin?
Yeah, around 29 to 32 Celsius degree.
Oh, 30, 39,
No,
29,
29
20,
to 32.
okay.
Yeah.
32, okay. Yeah, that's similar with in Indonesia.
Yeah,
That,
and very humid.
Yeah. But maybe in August it will be increased, right? August or July?
Yeah, it's increased July and keep until August.
August, yeah.
Yeah.
It's,
Now start the summer in Korea and it keep around 2 months.
okay.
Yeah.
So how many degrees the highest temperature during summer with Korea?
37, 38.
Oh, 37, 38, okay.
And it's around 70% or 80% humidity.
Oh, okay.
Yeah,
70%
very humid. Yeah, very humid.
Yeah. Okay, we reached the time. It is 10 a.m. in Kalimantan. So it would be 11, right?
Yes.
Prof. Shin in Korea.
Yes.
Yeah. Okay. So okay, I will open this session. Good morning, everybody, and also good afternoon, maybe friends in Korea. Soon will be afternoon. Okay, we'll doing our session in summer course today. So Professor, sorry, I will read before I will start, I will read a short CV from Professor Soo-Jeong. He is a professor in Department
Recording
of
in progress.
And Paper Science, College of Agriculture, Life and Environmental Science, Chungbuk National University. Professor Soo-Jeong was graduated from National University, both bachelor and also master degree. And then the PhD is graduated from State University of New York. And the recent interest is about biomass chemistry, green chemistry, environmental chemistry, and polymer chemistry. So current project is about cellulose nanofibril and also chitin nanofibril. So hopefully the topic that shared by Prof. Shin will be interest for us, and hopefully some of the audience can go for further study. Yeah, would be master course or PhD course in Korea. I hope Prof. Shin, some of the audience can contact you, and then discuss about his further study. Okay, so Prof. Shin, you have 1 hour. So it divide in your presentation and then question and answer. So please feel free if you please. Now I give you time to share or give your presentation.
Okay, thank you for bringing me to your courses. And I'm this is Soo-Jeong Shin from Chungbuk National University. And nowadays I'm research on many things about the biomass chemistry and nanocellulose. Also, I'm research for pulping, chemical pulping, like the craft pulping and soda pulping. So let me introduce to you. This biomass are composed by the cellulose, hemicellulose, and lignins. And many of the
excuse me. Could you slideshow, please? So it can be bigger in the.
Oh, bigger. Okay.
Yes. Slideshow.
Yeah.
Okay. Thank you very much.
So the biomass are composed by the cellulose, hemicellulose, and lignins. In hemicellulose, there are many different kinds of the hemicellulose, glucomannan things and xylans. Many softwood hemicellulose come from the glucomannan, but hardwood or annual plant is composed by the xylan hemicellulose. And another sort of things are lignin, and these lignins are a polymer of the phenylpropanoid units. And these lignins are hinder when we use this biomass as the pulping or other kinds of cellulose purification. Yeah, cellulose are composed by the glucose, and they are connected by beta wafer linkage, and they have a very regular shape. So yeah, we call in cellulose there are two different regions. One we call those crystalline area, and another things we call those amorphous area or paracrystalline area. In crystalline area, cellulose are very regularly arranged by the intermolecular hydrogen bonding and intramolecular hydrogen bonding. And this kind of the intermolecular hydrogen bonding and intramolecular hydrogen bonding make cellulose very, looks like the crystal structure. In wood, there are many cells. And yeah, these wood cells are composed by the S1 and S2 and S3. Yeah, we call those things a secondary wall, and there are primary wall. But most of the wood cells are secondary wall, and within secondary wall, S2 layers are the main things. When we check out these wood cells, there are many microfibrils, and these microfibrils are composed by the elementary fibril. When we go down to the cellulose nanofibril, we separate this cellulose to elementary fibril level. So yeah, there are cellulose very regular area and less ordered area. So in this cellulose, we can cut down this very regular area by chemical method or mechanical method, and we can make the cellulose to nano size. For these things, we should remove the lignins. So in lignin removal process, we use two different concepts. One is the delignification step, and the other things are breachings. In delignification steps are very similar to chemical pulping. So in most of the chemical pulping mills use the Krebs pulping process, and in Krebs pulping process, there are two chemicals, sodium hydroxide and sodium sulfide. But this sodium sulfide make very egg rotting smell, very bad smell. So in another process, you can use the soda anthraquinone pulping. In this pulping, we can use the sodium hydroxide with anthraquinone as the catalysis. In breaching process, in pulping process, we remove the lignin by hydrolysis, and it's cheap and easy. But some of the part of the lignins are very resistant to this hydrolysis process, so we need other oxidation process. So breaching process oxidize the lignin by some breaching chemicals. In most cases, we use the chlorine dioxide or hydrogen peroxide. Many years ago, we used the chlorine or hypochlorite, but those chlorine or hypochlorite make the problem in water pollution. So these days, we do not use the chlorine dioxide, chlorine or hypochlorite. Is there any problem?
No, it's okay.
Yep,
Yeah.
Okay. So this picture is the anthraquinone is how can anthraquinone working as the catalyst? In anthraquinone, oxidize the lignin to break down the lignin by the oxidation, and this reduced the anthraquinone convert the cellulose to oxidized form and go back to the original anthraquinone form. So these anthraquinones are oxidation and reduction cycles, and they can be used as a catalyst. So in one of my research topics, cellulose nanofibril, we can use make the cellulose nanofibril by natural resource like the tree. But some case, we can get the cellulose nano nano cellulose come from the bacterial cellulose. So we growing the bacterial cellulose and they make the biosynthesis by monosaccharide to cellulose. And there are some different kind of the nanocellulose. One from the mechanical things and the other come from the chemical things. In chemical things, we can hydrolyze all the amorphous region or paracrystalline region, so we can only keep the crystalline cellulose, and we can make those things to nano size. We call those things cellulose nanocrystal. These cellulose nanocrystals are similar but very different to microcrystalline cellulose. Microcrystalline cellulose are only remove the microfibril size, not the elementary fibril size. And cellulose nanofibril by some kind of the machine, we use high pressure homogenizer or microfluidizer or supermass collide. So after we make the nanocells, we can apply in many different areas. So these ones explain the cellulose nanocrystal. So in cellulose, there are two different regions, one crystal region and the other less crystal or amorphous region. With the sulfuric acid or what's the HCl, we can hydrolyze the amorphous region completely and make this crystalline region cellulose. And after that, we make this cellulose, crystalline cellulose region, we can sonicate to separate this each cellulose nanocrystal to sonificate. So this kind of material we call cellulose nanocrystal. But in the surface of this cellulose nanocrystal, there are some sulfonyl group from sulfuric acid treatment. So there are many these sulfuric groups from the sulfuric acid treatment. We can make this kind of cellulose nanocellulose by different methods. So we can make those wood chips and pulp. This pulp have the size of the micrometer scale size, and we pre-treat this pulp with some kind of different pre-treatment, like the carboxymethylation or temp oxidation. We can nanofibrillate to this kind. This one is around 2% of the cellulose nanofibril, and this looks like a gel and very sticky things. And you can use this to many different industrial areas. So this picture explains the different cellulose nanofibril makings. There are one machine we call supermass collider. These machines made by a Japanese Masco Sanyo company, and so grinding types. And there are another kind of the machines we call microfluidizer or high pressure homogenizer. This microfluidizer or high pressure homogenizer have very similar mechanical treatment, but some different things. With this kind of the mechanical treatment, we can get the nano size fibrillation, and we can put this in paper and make it very strong, or CNF film, or many different applications. These reactions are carboxymethylation reactions, and we can use these carboxymethylation reactions to carboxymethylate to cellulose. We already made this carboxymethyl cellulose in commercial, and these carboxymethyl cellulose are used in some kind of the toothpaste or ice cream for viscosity adjustment. So for this carboxymethylation, there are cellulose. These cellulose are ionized by the sodium hydroxide, and we can put these anions in this 6-position hydroxyl group or 2-position hydroxyl group or 3-position hydroxyl group. And this 4-position should be connected by the beta-1 linkage. And this ionized this anion cellulose attack this monochloro acetic acid and this part and make the SN2 reaction, and cellulose anion of cellulose are connected to this part, and these chloride anions are kicked out, and they form like this position, 6 position or 2 positions, 3 positions. Part of these positions are make the carboxymethylation. Commercial carboxymethyl cellulose degree of substitution level to 0.6 to 1.5. But when we use this to nanocellulose making, we decrease the degree of substitution to 0.1 to 0.4. If you increase the degree of substitution 0.6 to 1.5, you can get a very clear gel by just commercial mixer. But without when you decrease this degree of substitution around the 0.1 to 0.4, only previous machines like supermass collider or high pressure homogenizer or microfluidizer can separate this cellulose to nano size. Another reactions are tempo-mediated oxidation reaction. Originally, these tempo-mediated oxidation reactions are applied to the paper recycling industry, chemical pulp recycling industry. In chemical pulp, many recycling bring the so-called honification. After many recycling of the chemical pulp turn to very stiff and they lose the flexibility. So with this kind of the tempo oxidation, part of the cellulose hydroxyl group in C6 positions are oxidized to aldehyde, and finally they turn to the carboxyl group. So part of the cellulose oxidized to carboxyl group means they improve the flexibility and improve the hydrogen bonding ability to honify cellulose. But this process can very similar to carboxymethylation reaction, but this oxidation reaction. So the isogai groups they apply this to nanocellulose making. So when you oxidize part of the cellulose to like this carboxyl, the tempoxyl carboxyl group is well separated by the electrostatic repulsion by cellulose. So if you go to the carboxymethylation or tempoxidation, you can easily get the nanocellulose without those chemical pretreatment. One of these machines, this come from the Masuko Sanyu, Japanese company. They made this grinding type nanocellulose making equipment. Without carboxymethylation or tempo-oxidation, around 200 passes of this repeated operation only get the very near the nano size cellulose. But with good carboxymethylation or tempo-oxidation, only 2 or 3 passes of this using this machine, we can get the nano size cellulose. So with the chemical pretreatment, we can save the energy cost of this machine. And another method to nanocellulose making is a high pressure homogenizer. In high pressure homogenizer, we can pass through the very narrow gap between this moving part and the stator. There, we apply very high pressure. And when we pass through this narrow gap, they separate the microfibril to elementary fibril size. And this is one of the machines of high pressure homogenizer. And originally, this high pressure homogenizer are used more than 100 years in milk industry. Yeah, in milk, there are around 3.4% of the fat. So, yeah, in water and fats are phase separation. But when you drink some milk, there are no phase separation because the fat particles are passed through this narrow gap with very high pressure. They make very small size of the fat drops around the few nanometer size. And during milk transport and keep in the market, there are no nano size of the fat make agglomeration. So this, but these days, many different industry use this high pressure homogenizer too in different purpose. In cosmetic area, with this high pressure homogenizer, they can make the nano size emulsion. Without this high pressure homogenizer, they can only make the micro size emulsion. And if you make the nano size emulsion, this nano size emulsion have very high penetration to skin and improve the cosmetic effect. One different method of microfluidizer, they have a very similar mechanism to high pressure homogenizer, but a little bit different machine design. But one of the defect of these microfluidizers are they cannot make the commercial scale. It's good for lab scale, but they have very difficulty in pilot plant scale or commercial scale. After you pass through the supermass collider or high pressure homogenizer, this microfibrillate cellulose go down to elementary fibril size. So the left one is the scale bars are 200 nanometer and the right side microscope images are 100 nanometer. In most cases, this width of these fibrils are 5 to 10 nanometer size. So, but length of these materials are different by different treatment, but it depends on material and method. The length of these materials go to 100 nanometer to 1 micrometer. So after the nanofibrillation, we can get the very clear things, or these clear things means they have very thin width of the cellulose. Passing through the visible light depend on the width of the cellulose nanofibril. If we get the very thin cellulose nanofibril, they can go to transparency materials. And the right things are different nanomaterial with different passes or different grinding or different passes of high pressure homogenizer. Some wider width of materials looks like the white, but they go to narrow width material, they change it to looks like the crystal ones. These days, there are many applications in this kind of the nanocellulose. In Japan, they use this material to in ball pen and make this very clear writing. Some of the poor rheology things, when you write down, some inks are remaining in ball pen or like that, by this nanocellulose containing ball pen have very clear writings. Another things like this nanocellulose, they have high affinity to absorb the bad smells. So they put in the sanitary product. Another applications are in the shoes. They put in the gel. This gel come from the cellulose nanofibril gels and put in these shoes, and that's the decrease the damping of the things and improve the shoot quality. So these days, this ASICS company put the cellulose nanofibril in some part of the shoes. This one is different. This one come from the cosmetic product from the Nippon paper industry. So you can imagine why the Nippon paper make this cosmetics. But all the most of the ingredient this cosmetic come from the cellulose nanofiber. So they make the cellulose nanofiber for the humectant and cellulose nanofiber to rheology modifier things, and they replace many cosmetic ingredients by cellulose nanofiber. So in cosmetic, they put the carbomer for rheology control, and they put some hyaluronic acid or many different high hydroxyl group containing things for humectant. But they make this humectant or rheology modifier by change the different types of the cellulose nanofiber. So so Nippon paper try to try to their products to commercialize and buy this cosmetics. So they try to sell their product to cosmetic company, and this one is for the promotion to cosmetic company. Okay, I don't have the time. So, I only spent half hours. I explained so quick. Okay, is there any questions?
Okay, thank you very much, Professor Soo-Jeong Shin, for your nice presentation and very valuable for us. So now time for discussion. Please, if anybody wants to ask, raise your hand, or you can directly unmute your speaker, please. Okay, nobody. Okay, Prof. Soo-Jeong Shin. So in earlier you mentioned about the CNC or cellulose nanocrystal can be used for medicine. So my question is, what kind of medicine can be used from CNC?
In medical areas, we can use the cellulose nanocrystal. Looks like the previously microcrystalline cellulose are used in the many medicine medicine area. So when we make the pill, there are effective components are very small, and they adsorb on the surface of the microcrystalline cellulose. But microcrystal cellulose have very limited amount of the specific surface area. So when you change these things to cellulose nanocrystal, they increase the specific surface area, and they can put more things. So in the case of the very hydrophobic drugs, they have a very slow equilibrium to our body, and so we can make the cellulose nanocrystal with the hydrophobic drugs and make the longer lasting drugs and slow releasing drugs, because if we adsorb those kind of the hydrophobics, and they have a very low equilibrium to the water system and blood system, they have a very slow releasing. So many in pharmacist groups are focused on those things to make the patchy our skin, and it's lasting around 6 months like that.
Okay, so the active compound from medicine will be bonding with the CNC, right?
but
Okay.
they should be very hydrophobic. Otherwise,
Yes,
quick,
yes.
quick, equilibrium.
So the K is the hydrophobicity, right, from CNC. Yeah,
No,
mostly
no.
the
CNC is very hydrophilic, but they have
Okay.
large area of surface area, and that team, the adsorb, even though hydrophobic some drugs, and hydrophobic drugs are released very slowly.
Okay, it will be released the drug very slowly. So, okay, is there any question from anybody in the room? Please. So yeah, okay, we will wait. So my second question, Prof. Soo-Jeong. So mostly the CNC or cellulose nanofibril, it made by fresh wood, right? From example, we got to the forest and then take the wood and then process it in the mill, and then we got the CNC. So my question: how about the waste wood? For example, like old building, we got the wood from old building or anything wood waste. I think old wood. For example, building with wood very long, and then can we get the CNC a good quality as the fresh one from the forest, for example?
Yeah, I think so. The waste would have no problem to make the cellulose nanofibril or cellulose nanocrystal. But some of the wood have the preservatives. They could be very if toxic material containing things cannot use, but other things, if they do not have the toxic material, they can be used for raw material for
How about the fungi attack? For example, Shin. For example, the old wood is sometimes contain the what they call wood, right? Fungi, right?
Yeah, it's no problem. During processing, all the fungi could be removed, and we can sanitize by the pulping process or other process.
Okay.
So no problem to use the some rotten wood. Okay.
Okay. Thank you very much. So, is there anybody who wants to ask something? Simple question or Indonesian language is okay. I will translate to Prof. Soo-Jeong. Please. Bu Arlinda, do you have any question? Prof. Soo-Jeong, there is one question from the chat room. Okay, so I will read it. Is that all biomass could process being a gel? Last part of your presentation, so you explain about gel. So is that all biomass could be processed being gel?
We can make looks like a gel. All biomass. But when I try the bamboo, it's very easy to separate the microfibril to elementary fibril. So they are better than other kind of the commercial hardwood or softwood pulp. And so one time I focus on the bamboo. And
how about the grass? The grass.
It's okay, but in the grass, they have very low yield of the cellulose.
Low cellulose.
Yield.
Low cellulose. Okay. Is there anybody who wants to ask question, please, in Indonesia? It's okay. I will translate. Bu Yusniwati, you can ask your question. Anybody?
안녕하세요, 교수님. This is Rahmini. Maybe for the first time, I wonder why you are interested in cellulose nanofibril research.
Okay, long story. My background, pulping and bleaching. So what I'm doing is make the paper raw material. Around the early 2000, there was the very high price of the gasoline. So there are many projects to cellulose to ethanol or cellulose to alcohol. So I focus on the cellulose to alcohol making, ethanol fermentation, butanol fermentation, and how can I make the cheap glucose. But during those research process, those ethanol or butanols are very cheap, so I cannot make the money. Or if this cannot make the money, means my graduate student cannot get the job. So at that time, I thought the cellulose nanofiber is more expensive than the ethanol or butanol. So it's better to change the research. And so I focus on the cellulose nanofiber for commercial application things and those things. So nowadays I have I make the company. So right now I have the CEO and the Professor together. So I have some pilot plan of the supermass collider and pilot plan of the high pressure homogenizer in different place. And so some of my students these days, they still focus on cheap glucose making process to other things. These days we focus on more things to like the green hydrogen. So you can make the glucose and fermentate to making the hydrogen means green hydrogen. Also, some of my students are focused on the lactic acid fermentations. So we can make the cellulose to glucose and lactic acid fermentation. Those things can make with the lactic acid, we can go to polymerization to polylactide. Polylactide have very clean, transparent, looks like plastic, and they go to very good biodegradability things.
Okay. Thank you, Prof. Shin. Is there any question from the room? Please. Prof. Shin, until now, what kind of product from the nanofibril that you have already produced, or you already make a prototype of something?
I will try to sell those to cosmetic companies. So nowadays, as the cosmetic raw material, I try to sell cosmetic company, and also I'm working for processing, nanofibril processing. Someone else bring their own raw material and make the nano material. And I work for them for nano material making process. So
so you mean you combine for the cosmetic material, you combine this CNC or cellulose nanofibril with the active compound of the cosmetic, right?
Yeah. And when we make the nanocellulose looks like gel, around 0.2%, they make very regular structure. When I freeze dry 0.2% of nanocellulose gel, they do not make the particle. They make the looks like a sponge because they make very regular shape of the certain forms, and those kind of things. Nowadays, many sun cream, UV protection sun cream companies try to use those nanocellulose to making the very even distribution of the titanium dioxide or zinc oxide things.
So when you make a nanofibril, cellulose nanofibril, do you use like a titanium or gold or something or silver to make a nano?
No, but when we make the sun cream product, in product, part of the titanium dioxide or zinc oxide are agromolate, and they decrease the efficiency. But with the cellulose nanofiber, they improve the dispersibility of the zinc oxide or titanium dioxide. Yeah, and they improve the sun cream product, the ability to protect the to UV.
Okay, that's very interesting. Okay, in the chat room or in this room, is there anybody wants to ask something or ask question, please? If you have make another question. Prof. Shin, for last question. So, because most in this chat room is a student, mostly, so my question is, how, if they want to study in Korea, especially with you, what kind of requirement? So, please.
First thing, good writing skill. Write down the paper is most important thing. Second, good experimental skill.
Okay, experimental skill.
Good written communication.
Okay, good communication, experimental skill, and good to write the article, right?
Yes.
Okay.
Enos.
Yes, please, Samarinda.
Yes, thank you for the time. A very interesting topic. Thank you for Prof. Shin. I would like to ask one question about the source of the CNC. So which one is more better, the wood from trees or the plant that has a rich of starch to make a CNC?
Excuse me, would you speak again?
So to producing the CNC, which one is the source, the more better from wood of trees or the plants that having much starch?
I think the annual plant is better than wood, but problems are they have very low yield.
Low yield.
So
it's much better with the wood of trees have high yield.
Higher yield.
Okay.
In annual plant or perennial plant, they have very low yield to cellulose. Biomass to cellulose yield too low. So, but softwood, hardwood, they have very high yield to cellulose.
Okay. Okay, thank you.
Okay, thank you very much, Vale. Is there any question? Prof. Shin, so is there any scholarship in Korea?
I think there are one scholarship from Korean government and
Korean government, okay.
So it's all included. From your departure to return to Indonesia, they have all included. Last year, one of my graduate students selected Korean government scholarship, and it supports 3 years. So you can apply Korean government scholarship in Indonesia, but you can apply, come to Korea and during master and applying scholarship. I think around 7 people of this in forestry area, 7 of the government scholarship from Korean government.
Okay, thank you for information. Hopefully that the information will be catch up by my student, and then they can apply for the scholarship to study in Korea. Mostly Indonesian, mostly Indonesian students, they love Korean drama. Korean drama. Mostly, not only the student, but already the mothers also love the Korean drama. Okay.
Until this year, I forgot applying the research money, but this year and next year, I'll try to find out the research money for
Okay.
After that, I try to find out a good graduate student candidate. Okay.
Okay.
Yeah.
Thank you very
So
much. For
if
the
there are
info.
any good students, please introduce to me. Okay.
Okay. Thank you very much for that
Yeah.
opportunity.
Yeah.
Okay, the student, you already hear that. The announcement from Prof. Shin. So please be ready. Yeah, just prepare for your ability, experiment ability, and also good communication ability, and also writing the article ability. That's
And
the most.
one of the things these days I'm working with other research organization in Korea.
Yeah.
And they asked to me find out the research assistant from those research organization, and they can support you, but attending the graduate to Chungbuk National University. So one of my graduate students work like that. So around what's that? 4 days
Okay.
per week with the work for those research organization, and come 1 day to graduate class. So if there are anyone interested in the, I can introduce to those research organizations.
Okay.
Okay.
Okay. Thank you very much for the info, Prof. Shin. Okay. So for the last one, if anyone wants to ask, I still open one question. Yeah, Ramini.
His name, if we make a CNF from different raw materials, will they have different properties?
Yes, maybe. Yeah, each material is very different. So when I check it, the bamboo, those bamboo show very different CNF property with the hard of the pulp or soft of the pulp. So different raw material have a different cellulose crystal, maybe different cellulose crystal structure, and those things are connected to different material property.
Okay. Okay. Thank you very much, Prof. Shin.
Yeah.
Okay. So for the last, Bu Harlinda, Prof. Shin, we will give you the certificate for this summer course or the session.
Yeah.
So Mrs. Harlinda will give you the certificate, please, Bu Harlinda. Or
okay.
Okay, now it's the end of the class.
Okay, this is our appreciation to Prof. Shin, certificate for the speaker today. Thank you very much for your the material, the topic from biomass to CNV. I'm sorry, cellulose nanofiber today. Thank you very much, Prof. Shin.
Okay, thank you.
Prof. Shin, so we this summer course, this is the first summer course held by our faculty, Forestry Faculty of Mulawarman University. So next year we will have the other one, the second one.
Yeah. So if you invite me, I'll talk the different subjects like the cellulose to glucose and glucose to different all different kind of the fermentation things. Yeah.
Yes. So we also have beside this course, we also have the camping ground. We will go to camping. Yeah, forest camp.
Forest camp.
So so we will going to the forest and camping in the tropical rainforest near the capital city, next capital city of Indonesia. So hopefully next year we will invite also your student can come to Indonesia. Join the camp.
Okay,
it's very interesting. So because in that forest, tropical rainforest, mostly old secondary forest. Yeah, that's the type of the forest. So we will contact you for the next summer course. So your student can come.
Okay.
Prof. Enos, next year we have
Yeah.
international symposium for.
Okay.
Yeah.
So we can
So you-
invite also.
Yeah, we will invite Prof. Shin
Yeah,
to East
to come to
Kalimantan.
Kalimantan. Yeah,
Please,
East Kalimantan.
please come, Prof. Shin.
Prof. Shin,
Yeah.
is it possible? For us to make a MOU or a collaboration?
Yeah.
Your
Okay,
labo and
yeah.
our faculty, or your faculty between our faculty.
Okay. Yeah. Okay. Yeah.
Yeah, if possible, we will send, for example, draft of memorandum of understanding. So yeah, it will be connecting our faculty and your faculty, and also include your student, and our student can exchange with the government, with the government money or finance.
Okay. Yeah.
I think will be interesting for student exchange, and also for maybe also for the staff exchange in laboratory or lecturer exchange. Yeah.
Okay. Yeah.
Yeah.
Okay. Yeah. Okay. Yeah.
We will contact you soon, Prof. Shin. Thank you very much for
Okay.
your valuable course or lecture today. Hopefully we can see again, and whatever in Korea or Indonesia next time.
Yeah.
Okay, thank you very much.
Okay. Thank you. It's
Thank
my
you very much.
pleasure. Okay. Yeah.
Thank you.
Thank you very much.
Prof. Shin, thank you, Prof. Enos.
Yeah.
Recording stopped.
Ramini.